All right, so this is the first lesson video, and I wanted to kind of go over a few things because this covers units and it also covers the trig background stuff. So essentially, what I wanted to make sure is that everyone was on the same page in terms of where they were in that comfort level for that information, right? So a couple important things first. Um, Specifically about the unit questions is that basically you're not going to have to actually convert the units like that on an exam because would become really difficult for the professors to have to sit here and write the exam in like half metric and half American units, right? So that was mostly just to familiarize yourself with paying attention to units. So it's definitely still important to pay attention to them because they're a part of every correct answer. But you're not going to have to keep going back and forth between like kilometers and feet and stuff like that. So definitely familiarize yourself with paying attention to them because units and sig figs are considered in the correctness of an answer, but you don't have to convert between metric and American. So that being said, I think the next big thing to go over is trig, and that's probably the biggest thing to go over. Um, the most important things are SOHCAHTOA, right? And there were a few people who haven't heard of that before, which is totally fine. But I just wanted to um, clarify that for those people and review it for those who have heard it. So if you said that you haven't heard of it in class, I went over it with you. So if you told me you haven't heard of it, you should have gotten some introduction to it when I was in class with you guys, but I kind of wanted to go over it just a little bit more here. So these are only true for right triangles, so that's important. But that being said, those are the only triangles you'll see in this class. So that's fine. So say I have this triangle right here, and I was given this angle is, let's say, 30 degrees, and this magnitude here, this hypotenuse is, we'll say 20, right? And I want to find the height of, we'll call this side A and side B, right? So that's where SOHCAHTOA comes in, because essentially the hypotenuse of that triangle is the entire magnitude of the length from here to here, right? So essentially by breaking it up into sides A and B, you're finding exactly what portion of that entire magnitude goes in the X direction and what portion of that magnitude goes in the Y direction, right? So for example, or I guess to review quickly first. So here means that the sine function refers to the opposite side over the hypotenuse. And then the middle part, the ka, means that the cosine function refers to the adjacent side over the hypotenuse. And then the tangent function, oh wait, no. The TOA part, sorry, refers to the tangent function, and it relates the opposite side and the adjacent side. So essentially, it's a way of relating the magnitudes of the sides, and that will allow you to scale this magnitude because they all have the hypotenuse related to the sides. If you're given both or neither of the sides, TOA is kind of a little bit useless unless you're looking for the angle. Um, but we'll get into that in a different video. So in terms of using SOHCAHTOA in this kind of situation here, what you're going to end up doing is, so to describe side A, I know it is some scaled version of the 20. So I know that I'm going to be scaling the 20 by some value. And that value is going to be less than 1 because you know that the length of the hypotenuse is the longest length in the triangle, right? So this number here should work out to less than 1. So if I'm looking at side A, oh no. If I'm looking at side A here, and this is the angle I'm given, how is this side related to that angle, right? And because it's across the triangle from that angle, that means it's the opposite. So now I have to figure out which one relates the opposite and the hypotenuse, and that is sine. So here it's going to be 20 times the sine of that 30-degree angle. Similarly, right, if I'm looking at B, which is the bottom side here, and I'm relating it to this angle, how can I figure out which trig function to use? Well, I know if I used sine on this side, on side A, side B has to be cosine. But if I'm starting with side B, how would I figure that out? The easiest way that I've found is that this little arc thing here that labels the angle is always going to touch the hypotenuse, but it's always also going to touch another side. And the other side that it touches will always be the cosine side, because adjacent means next to or near. So because of that, I would use the cosine function, so the cosine of 30 degrees, to find the scaled value of that side. And then to verify that, because it's a right triangle, what you could do is say, okay, I know that a squared plus b squared is going to have to equal 20 squared. So once you find these numbers, I'm not going to do that in the video, but once you find the values for a and b, what you can do is you can go in and say, all right, well, I can plug them in here and here and verify that they actually equal 20. So that's SOHCAHTOA. That's the first thing I wanted to go over. What I would do for sure is that something that we didn't get to go over in class is the scalars and vectors worksheet. It's the one after units and before the trig review worksheet. I would absolutely recommend doing that because it's kind of related to this information and it's definitely critical for moving forward in the class. In terms of content, that's the only thing I really wanted to go over for lesson 1. But I would definitely recommend that you familiarize yourself with SOHCAHTOA because that's super important. Maybe, you know what, maybe we'll also go over the slope triangles thing because that was something a lot of people also haven't seen before. So if I have a line here, right, and I'm given that the slope relationship here is 3 and 4, right? So you know that similar triangle that has 3 and 4, that's a right triangle, is going to be a 3, 4, 5 triangle. So I already know that that's the ratio there. If I also was given that the magnitude of this vector here was 50, I can use that relationship here, similarly like I did with the sine cosine functions up top, to scale down that 50 into what directions it goes in, right? So I know that this 50 has to go in some direction that way, to the right, and then some direction up, right? And that forms a right triangle. So basically this blue triangle that I've just made is a similar triangle to the smaller one. I just need to figure out what kind of ratio scales it up. So same thing, I'm going to call this side A and side B. And if I want to find side A, again, they're going to be smaller. So I'm going to multiply it by something smaller than 1. But it's all going to be related to the magnitude. Right, so side A, I'm going to try to match up this triangle, the red triangle here, with the blue triangle. And in this case, it's already matched up because this right angle is in the same position, right? So basically, it's already set up pretty easily. So I know that this side A has to be some scaled version of 3/5 of the larger magnitude. So basically this angle here to find side A is going to be, not this angle, this fraction, I'm sorry. So side A is going to be 3/5 of that hypotenuse as defined by this slope triangle. Side B then is going to be 4/5 because that's the other side length here, but it's also because that corresponding side on that slope triangle matches up with the bottom of this triangle. So that was a really fast version of describing that, and I'll go into that a little bit more in lesson 2 with resultant forces and force components, but I just wanted to kind of introduce that as a different trig relationship, because as we move forward in this class, you're either going to be given the actual angle like you were here to describe the direction of a force, or you're going to be given a slope triangle like that to describe the relationship of the directions of a force. So these are the two trig methods that you can use to understand or define the direction of a force, and all of that is trig related. So my recommendation to you would be to absolutely come to office hours if this is still confusing to you, because this is going to be used from now until the end of the class in May. So please reach out with any questions. If you don't have any, I will see you in class.